Hi, for those of you who don't know me, my name is Sloane. I am a first-year graduate student at WVU. I'm currently working with Dung, and today I'm going to be talking to you about simulating the true repeater rate of fast radio bursts. So one big question right now is whether or not repeating and non-repeating FRBs come from different progenitors. And if they come from the same progenitor, then are all FRBs going to repeat? Parameter space has not really given us a definite conclusion. As we can see here, these are from Chime Catalog 1, which I'm sure we're going to be hearing lots about over the next few days. There are certain parameters that imply an intrinsic difference in repeating and non-repeating FRBs, things such as DM and spectral index, spectral running. Then there are other properties that don't really imply a difference between repeating and non-repeating sources, such as the scattering time. So a big question is, are current observations consistent with an entirely repeating population? Yamasaki et al. 2024 found that the Chime catalog was consistent with a fully repeating population within one standard deviation. So from here, we're attempting to then test that hypothesis. So just an overview of Chime Catalog 1. The Chime telescope sweeps the entire northern skyline every single day. The first catalog came out a couple years ago, approximately 530 FRBs, just over 60 of which came from repeating sources. It was the largest FRB catalog to date. We expect the second catalog to come out in the next couple of months, which we expect will then add a lot of new FRBs. So how are we going to simulate this FRB population? We're going to follow the framework of the paper I mentioned earlier, Yamasaki et al. So the first thing we want to do is assume a uniform sky distribution of FRBs, and then from there we're going to get our selection function. And then next we're going to take a power law burst rate distribution and find what parameters we think best to model the FRB population, and then we're going to run our simulation and say, does it match catalog 1? So the first thing we're doing is modeling chime detections. As you can see here, the number of detected sources scales heavily with declination. That is because chime sensitivity and exposure both scale strongly with declination. So the way we dealt with this was we fit a polynomial to the Chime Catalog 1 dataset, and then we compared this with the assumed all-sky distribution, and the difference in the two then gives us our selection function. And I want to note that we only used FRBs from the second half of the Catalog 1 timescale, because otherwise, at the beginning of Chime Catalog 1, there was a lot of uncertainty in the sensitivity, and we wanted to make sure that we could model chime approximately with this simple model. So the next thing we do is we want to investigate our fit parameters. And I want to note that a lot of things have been mentioned in the past few talks, such as rotation measures, scattering, all these things. We're kind of just using a bare bones approach. We are just saying how many FRB sources are in the sky that Chime could see, and will they see a burst. We're not implying anything about morphology or anything like that. So Yamasaki et al. Concluded that Chime was coincident with a fully repeating catalog. We tested their parameters with our analysis, and we determined that these parameters would predict about double the amount of repeating FRBs than were actually seen in Chime Catalog 1. So now that we see this, the question is, what parameters would better fit the Chime data? So this shows the chi-squared for a series of 100 runs of simulation with approximately 10,000 simulated FRB sources. These are the two parameters that we've really been playing around with to try and see how we can best simulate the Chime data. We look at the minimum R value and then our Q value. The maximum R value is set by the current Chime detections, which is approximately 10 to the 0.5 bursts per hour. So these ranges are ranges that have been looked at in current literature, where they're looking at the population of repeating FRBs. So as you can see, the lower Q values don't really do a great job of modeling the chime data, and we have a couple of promising little boxes on our plot, so we tested those, and we found that with a minimum R value of 10 to the minus 5.5 bursts per hour and a Q value of approximately 2.37, we can semi-accurately model the chime catalog 1 data. Obviously, it's not a perfect fit, but it shows that there is some promise to looking at the chime catalog as a set of all repeating sources. So you may be thinking, okay, cool, now what? Glad you asked. So next steps would be to kind of refine this model. If we use this model and we say, okay, it predicted chime catalog 1, well, then we can say, what does it predict for chime catalog 2? If we make predictions for chime catalog 2 and then chime catalog 2 comes out and our predictions match within reason, that could give some ground to stand on in this model. Another thing that we need to do is look at the different wait time distributions. As Doug had mentioned in his talk, certain bursts have exhibited clustering of their bursts with the repeating sources. So we did not account for clustering. We kind of just we said if it has this burst rate, it'll burst this many times in the catalog 1 timescale, and then we assigned each burst a random timestamp. So obviously we would hope in the future to take into account this burst clustering and see how it affects our model. And then one last thing that we could observe is we could look at models where FRBs maybe do not come from a single repeater distribution. There's been a lot of talk in the last couple of talks, and I'm sure there will be a lot more talk about whether or not all FRBs come from the same source. That does not say that they don't all repeat. They could all repeat and just have different progenitors, because there are talks of the highly active repeaters coming from a different source than maybe our less active repeating sources. So these are all things for us to look at in the future. And in conclusion, do all FRBs repeat? Unfortunately, I cannot give a very conclusive answer, but I can say maybe. Stay tuned. So in the future, we need to do more analysis of our parameter space to continue making predictions, and then we can say that catalog 1 may be described using a single repeating population, and we can say that a lot more will obviously be told once catalog 2 comes out. So thank you. Take any questions.
All right, I've got 4 minutes for questions.
What did the parameter Q represent again?
Q was, it was the power law relating the number of bursts for a certain repeater rate to the number of repeats of that burst. Yes.
Yeah, I'm just wondering, when you talk about comparisons with chime catalog 2, one thing is like their properties and distributions, but can you make any prediction just on the number that should be detected? Like if all of them repeat, eventually you're gonna kind of flatten out, right?
Yeah. So
Back into it.
with the catalog 2 timescale, I don't remember the exact number that we would predict. It would obviously be in the thousands, but unfortunately, off the top of my head, I don't recall. But I think we would need to refine our model a bit more before we'd be able to make any conclusive predictions for catalog 2.